Section 230.64 of the National Electrical Code states that service entrance conductors installed underground shall be encased in concrete or equivalent material, or run in a raceway approved for the purpose. The intent is to ensure the protection of service entrance conductors from physical damage. Concrete encasement of conduits provides protection against physical damage and helps maintain the integrity of the service entrance system. The concrete acts as a protective barrier against impact, abrasion, and other hazards. In situations where the engineer decides to only encase the conduits until they reach the main electrical room, this is acceptable if the conduits are then run in a raceway approved for the purpose. A raceway is an enclosed channel such as a rigid steel conduit that is used to protect wires or cables. Rigid steel conduits are strong and durable, and they meet the requirements for raceways approved for service entrance conductors. Service entrance conductors should be encased in concrete or run in a raceway until they reach the service disconnecting means, which is typically located at the main switchgear. The main switchgear is where the service entrance conductors connect to the building's electrical system. Therefore, the requirement for concrete encasement of the conduits up to the main electrical room is consistent with Section 230 of the National Electrical Code. The use of a raceway for the remainder of the run to the main switchgear is also acceptable. Service entrance conductors are the wires or cables that bring electrical power from the utility company's distribution system to the building's service equipment. These conductors are critical for providing electrical power to the building and must be protected from physical damage to ensure the safety and reliability of the electrical system. The National Electrical Code, or NEC, provides specific requirements for the installation and protection of service entrance conductors. Section 230 of the NEC covers service entrances, and it outlines the requirements for the type of wiring methods, overcurrent protection, and disconnecting means that must be used. The NEC also specifies the requirements for the physical protection of service entrance conductors. Section 230.6 addresses the protection of service entrance conductors that are installed underground. This section requires that service entrance conductors installed underground be encased in concrete or equivalent material, or run in a raceway approved for the purpose. The intent of this requirement is to protect the conductors from physical damage, such as from digging, impact, or abrasion. Concrete encasement provides a high level of physical protection for service entrance conductors. The concrete acts as a barrier against impact, abrasion, and other hazards that could damage the conductors. Concrete encasement also helps to maintain the integrity of the service entrance system by preventing the conductors from shifting or settling over time. The concrete encasement should be of sufficient thickness to provide adequate protection for the conductors. The NEC does not specify a minimum thickness for concrete encasement, but it is generally recommended that the concrete be at least 2 inches thick on all sides of the conductors. In some cases, it may be necessary to provide additional protection for the conductors, such as by using a reinforced concrete encasement. A raceway is an enclosed channel that is designed to hold and protect wires or cables. The NEC recognizes several types of raceways that are approved for use with service entrance conductors, including rigid metal conduit, intermediate metal conduit, and electrical metallic tubing. Rigid metal conduit, or RMC, is a heavy-walled steel conduit that provides a high level of physical protection for conductors. RMC is typically used in areas where the conductors are subject to physical damage, such as in industrial settings or underground installations. Intermediate metal conduit, or INC, is a thinner-walled steel conduit that provides a lower level of physical protection than RMC. IMC is typically used in areas where the conductors are not subject to severe physical damage, such as in commercial buildings or residential settings. Electrical metallic tubing, or IMT, is a thin-walled steel conduit that is typically used for indoor wiring applications. EMT is not suitable for use in areas where the conductors are subject to physical damage, such as underground installations. When using a raceway to protect service entrance conductors, it is important to ensure that the raceway is properly sized to accommodate the conductors. The NEC provides specific requirements for the number of conductors that can be installed in a raceway based on the size and type of raceway. It is also important to ensure that the raceway is properly supported and secured to prevent it from shifting or settling over time. The service disconnecting means is the device that is used to disconnect the building's electrical system from the utility company's distribution system. The service disconnecting means is typically located at the main switchgear, which is where the service entrance conductors connect to the building's electrical system. The NEC requires that the service disconnecting means be readily accessible and capable of disconnecting all ungrounded conductors simultaneously. The service disconnecting means must also be properly labeled to indicate its purpose. In some cases, the service entrance conductors may be run through a building before reaching the service disconnecting means. In these cases, the NEC requires that the conductors be protected from physical damage by being encased in concrete or run in a raceway. The conductors must also be installed in accordance with the NEC requirements for wiring methods. In summary, Section 230 of the NEC provides specific requirements for the installation and protection of service entrance conductors. Service entrance conductors installed underground must be encased in concrete or equivalent material, or run in a raceway approved for the purpose. The intent of this requirement is to protect the conductors from physical damage and to ensure the safety and reliability of the electrical system. When choosing a wiring method for service entrance conductors, it is important to consider the specific requirements of the NEC as well as the environmental conditions and potential hazards that the conductors will be exposed to. By following the NEC requirements and using appropriate wiring methods, it is possible to ensure that service entrance conductors are properly protected and that the electrical system is safe and reliable. Furthermore, always consult with a qualified electrical engineer or electrician to ensure that the installation meets all applicable codes and standards. Remember that the National Electrical Code is updated regularly, so it's crucial to use the latest edition when designing or installing electrical systems. Consider the specific conditions of the installation, such as soil type, moisture levels, and potential for physical damage, when selecting the appropriate wiring method and protection for service entrance conductors. Proper grounding and bonding of the service entrance equipment are essential for electrical safety. Ensure that the grounding system is installed in accordance with the NEC requirements. Regularly inspect the service entrance conductors and equipment for signs of damage or deterioration. Replace any damaged or worn components promptly to prevent electrical hazards. The National Electrical Code provides tables that specify the allowable ampacities of conductors based on their size, insulation type, and installation conditions. Refer to these tables to ensure that the service entrance conductors are properly sized to carry the intended load. Overcurrent protection devices, such as circuit breakers or fuses, are used to protect conductors from overloads and short circuits. Ensure that the overcurrent protection devices are properly sized and coordinated to protect the service entrance conductors and equipment. Properly label all service entrance equipment, including the service disconnecting means, overcurrent protection devices, and grounding connections. This will help to ensure that the equipment is easily identifiable and that it is operated and maintained safely. When working with electrical systems, always follow safe work practices, such as wearing appropriate personal protective equipment, energizing circuits before working on them, and using proper lockout-tagout procedures. If you are not qualified to work on electrical systems, consult with a qualified electrical engineer or electrician. In addition to the NEC, there may be other local codes and regulations that apply to the installation of service entrance conductors. Be sure to check with the local authorities to ensure that the installation meets all applicable requirements. Proper installation and maintenance of service entrance conductors are essential for electrical safety. By following the NEC requirements, using appropriate wiring methods, and adhering to safe work practices, it is possible to ensure that the service entrance conductors are properly protected and that the electrical system is safe and reliable. Consider the long-term maintenance requirements of the service entrance conductors and equipment when selecting the wiring method and protection. Choose materials and methods that will minimize the need for future repairs and replacements. Document the installation of the service entrance conductors and equipment, including the wiring method, conductor size, overcurrent protection device ratings, and grounding connections. This documentation will be helpful for future maintenance and troubleshooting. Regularly train employees on the safe operation and maintenance of service entrance equipment. This will help to prevent electrical accidents and injuries. Implement a comprehensive electrical safety program that includes procedures for hazard identification, risk assessment, and control. This program should be reviewed and updated regularly to ensure that it is effective. Conduct regular audits of the electrical system to identify potential hazards and areas for improvement. Address any identified issues promptly to prevent electrical accidents and injuries. Stay up to date on the latest electrical safety standards and best practices. This will help to ensure that the electrical system is safe and compliant with all applicable requirements. By following these guidelines, you can help to ensure that the service entrance conductors are properly protected and that the electrical system is safe and reliable. In buildings with multiple tenants, the service entrance conductors may serve multiple occupancies. In these cases, the NEC requires that each occupancy have its own service disconnecting means. The service disconnecting means must be readily accessible to the occupants of each occupancy. In some cases, it may be necessary to install multiple sets of service entrance conductors to serve multiple occupancies. The NEC provides specific requirements for the installation of multiple services. The service entrance conductors must be sized to carry the total load of all of the occupancies that they serve. The overcurrent protection devices must be sized to protect the service entrance conductors from overloads and short circuits. The grounding system must be designed to provide a low impedance path for fault current to return to the source. The service entrance conductors must be installed in accordance with the NEC requirements for wiring methods. The service entrance conductors must be protected from physical damage by being encased in concrete or run in a raceway. The service entrance conductors must be properly labeled to indicate their purpose. The service entrance equipment must be regularly inspected and maintained to ensure that it is operating safely. The service entrance equipment must be replaced if it is damaged or worn. The service entrance equipment must be installed in accordance with the manufacturer's instructions. The service entrance equipment must be installed in a location that is accessible for maintenance and repair. The service entrance equipment must be installed in a location that is protected from the elements. The service entrance equipment must be installed in a location that is free from hazards. The service entrance equipment must be installed in a location that is properly ventilated. The service entrance equipment must be installed in a location that is properly illuminated. The service entrance equipment must be installed in a location that is properly grounded. The service entrance equipment must be installed in a location that is properly bonded. The service entrance equipment must be installed in a location that is properly labeled. The service entrance equipment must be installed in a location that is properly maintained. The service entrance equipment must be installed in a location that is properly inspected. The service entrance equipment must be installed in a location that is properly repaired. The service entrance equipment must be installed in a location that is properly replaced. The service entrance equipment must be installed in accordance with all applicable codes and standards. The service entrance equipment must be installed in accordance with all applicable regulations. The service entrance equipment must be installed in accordance with all applicable laws. The service entrance equipment must be installed in accordance with all applicable ordinances. The service entrance equipment must be installed in accordance with all applicable permits. The service entrance equipment must be installed in accordance with all applicable licenses. The service entrance equipment must be installed in accordance with all applicable certifications. The service entrance equipment must be installed in accordance with all applicable approvals. The service entrance equipment must be installed in accordance with all applicable listings. The service entrance equipment must be installed in accordance with all applicable labels. The service entrance equipment must be installed in accordance with all applicable markings. The service entrance equipment must be installed in accordance with all applicable instructions. The service entrance equipment must be installed in accordance with all applicable warnings. The service entrance equipment must be installed in accordance with all applicable cautions. The service entrance equipment must be installed in accordance with all applicable notices.